Right, let's do a revision on magnetism. This chapter concept-wise is quite easy. Most of the concepts you know already. Okay, you've been taught before, and it's also quite commonsensical. Okay, so first of all, look at your notes. Okay, as I go through this, magnetic properties. I think all this you're quite clear, right? There are obviously two poles and such as this. Remember, for for a magnet which is suspended freely, it will always point in a north-south direction, right? And law of magnetism, okay, like poles repel and like poles attract. Okay, this is also quite obvious. So all this you just have to go through by yourself, like a experiment. How do you test for magnetized magnetic material, unmagnetized magnetic material, non-magnetic material? So go and read through yourself all this experiment over here. Okay, in case they ask, at least you can come up with a proper experiment on how to describe this. Okay, and the main thing to remember for this is, of course, that repulsion is the only sure test. So even though something may be attracted by a magnet, it doesn't mean that something is a magnet. It has to be repelled. Okay, so it's quite easy as far as concept-wise concerned. Okay, the next thing will be magnetic induction. Alright, so for magnetic induction, remember that a magnet can induce magnetism in other materials. For example, your paper clay, a paint, this becomes an induced magnet. Right? It doesn't even need to touch. It can be just in the within the area of the magnet's magnetic field. Okay, so know how to explain this, right? Know how to define what is magnetic induction. Okay, so this is something you need to know. Okay, and probably have to memorize as well, proper definition. Okay, if they just ask you to define or explain magnetic induction, say that it's a process where magnetic material becomes an induced magnet when it is near or in contact with a magnet. Okay, so learn the proper way of explaining this. And very often you will have questions being asked on induced magnetism. So sometimes they consist of quite a number of marks, and there's a proper way of phrasing your answer. Okay, and that one I will do later when we look at some examples. Okay, then after that there's the magnetic field. Again, the definition. Okay, something to take note of, something to remember. Okay, and then of course the drawing of magnetic fields, that is very important as well. How to draw and draw it properly. Okay, and always remember that I think one thing students always forget is the magnetic fields lines always go from north to south, so you have to draw a uniform magnetic field, something like that. Okay, my drawing is not very nice. At the end it curves. Okay, remember, at the end it curves. Okay, it should be uniform. Okay, maybe this is not very good drawing, north to south. Right, maybe I show you the book instead rather than my own drawing. Okay, so you see how the book draws it. Okay, uniform. Okay, north to south. Alright, and then when it is like poles, there's a repulsion. So these two lines start to run parallel each other. So make sure you have that. And then for full magnet north to south, how it looks like. So make sure you get this right. You shouldn't get this wrong. Make sure that the direction of the field lines point away from the north pole and towards the south pole. Okay, so always check for that. Okay, you should not get this wrong. Then after that, go and study the how you actually get the magnetic fields. Okay, you either use plotting compass or iron filings. Of course, iron filings just tell you the direction, just tell you the pattern, but not the actual direction of field. So this one probably takes some learning, okay, some memorizing, okay, and you have it over here, right? So that is for you to go and study. It's easy to understand. Okay, you can find YouTube videos showing this, but to describe word by word, sentence by sentence, maybe not so easy. Okay. Okay. So after that, we talk about making of magnets. So there's stroking. Okay. I think this one you've done in primary school, and the one thing to remember is, like, for you start with a north here, what pole is this? This will be a north. To me, I just remember this way. Whatever the pole you start with, this will be the same pole. So if this is south, it will be south. North, this will be north. Okay, so there's one thing to remember. Okay, of course, that is not the best method to make magnets. The better method is to use electrical method using direct current supply. So the setup is obvious. Okay, you have your rod. Okay, it's very simple to remember. Description also doesn't take too many words. And DC supply connected. Just close the switch, right? And then after that, after some time, this rod will become magnetized. If it's steel, it will retain its magnetism. You can use it as a permanent magnet. Okay? Alright. In relation with this, the main thing to know is how do you tell what pole is this? Right? We use our right hand grip rule. How does it work? Okay, it's not correct to say, oh, here's positive, so that means this is north. No, So you got to first of all, step one, look at the way the current flows. Current flows this way. And it goes here from front to back, front to back, front to back, front to back. So you could use your pen or pencil and then you imagine, okay, current is going from front to back. So my 4 fingers are following the direction of current. So it's front to back, front to back. So you check front to back, front to back. And where my thumb points is the north. So my thumb points to the left, this is my north. Then this is my south. Okay, so that's how you tell it using the right hand grip rule. Okay, so if let's say okay, you wonder how about this, if let's say it's going from back to front, so how will it look like? Okay, you again look at the way the current flows. Okay, current is going this way, right? Current is going this way. Firstly check for current flow, back to front, back to front. Okay, so my rod back to front. My 4 fingers go from back to front. You point this way. It means here would now be your north. That means this side will be your south. Okay, so that's how you tell the direction of the magnet. Okay, so make sure you know this. Okay. Okay, next, let's go on. Alright, so this is right hand grip rule. Then methods of demagnetization. These two everybody knows: heating, hammering. Don't say dropping. It's better use the word hammering. Best method of demagnetization. Okay, so you have your magnet. Okay, same thing, almost the same setup as before. Only difference is you connect to an AC supply. So the AC supply, connect switch here. Okay, place a magnet inside the solenoid. Okay, this is the solenoid, a coil of wire in case you still don't know. Okay, then close the switch. After that, we draw it away. Okay, with the AC still flowing, so it should be demagnetized. Okay, the main thing, the main thing I want you to remember is this. Okay, right? I put here 2 stars and so on. With a core or magnet still inside the solenoid that is connected AC supply, the core of the magnet will still retain its magnetic abilities. So what does it mean? It means that it can attract magnetic material. So if you were to put iron nail here, okay, it can get attracted, right? But what's the difference then? The difference is that its poles will be continuously alternating or changing. What does it mean? Okay, it means that this doesn't remain north and this doesn't mean south. This one is north, south, north, south, north, 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 south, all the way. Keep changing. Why? Because AC, the potential keeps changing. If here is positive, here negative, after very quickly, not after some time, here become negative, then positive, negative, positive, negative. So the current keep changing direction. So meaning here north, south, north, south, north, south, all the way. Okay, keep changing. So a good way of saying is that the poles will continuously rotating. So remember this phrase. This phrase is super duper useful when you are going to explain or answer questions. Alright? Okay, so then the next thing, iron and steel. Right? So iron, remember, is 3 words. It's not a soft metal, it's not a soft magnet, but it's a soft magnetic material. Okay, 3 words. You must remember the 3 words, they go together. Gains or losers is magnetism easily. Right? So the users, you can find them in electromagnets, loudspeakers, and so on and so on. Okay, steel is known as a hard magnetic material. Again, do not write hard magnet, hard metal. Very often we get this kind of wrong answers. And what's a hard magnetic material? It retains its magnetism longer. So you will use it in anything you want where you want the magnet to remain a magnet for a long time, like a magnetic door catch, a DC motor, AC generator, or a compass needle. Alright, compass needle. You will use materials made of steel. And also, so take note of this: a hard soft magnetic material for iron, hard magnetic material for steel. And which one is stronger? Well, iron has a stronger magnetic strength than steel. Okay, and how do you determine the strength of magnet? Okay, you can see the number of paper clips it can attract in a straight line, right, like that. Don't just say how many paper clips can attract, but in a straight line, in a row, right? That's a fairer than just say how many can it attract, right? So the iron should attract more than steel, right? So concept-wise, that's about it for this chapter, right? The rest is all about explaining and so on. Okay, so I will break this. This will be part 1, and in part 2 I will just go through some how you explain your magnetism answers and how you write answers. Okay, so you still need to study all this. Okay, you need to go through things, especially things which need some time to learn how to write, like for example plotting a magnetic field lines with a compass, okay, and other things like right hand grip rule. Other than that, it's quite easy. Okay, and the rest is just about being very careful. Okay, right, so let's stop this here and then we talk about our approaches.